Hola, buenos días a todos. Me voy a cambiar para inglés porque mi castellano es muy malo, entonces es muchísimo mejor para vosotros hacer la comunicación en inglés. Es un placer enorme estar aquí con vosotros y agradecer el convite impulsado por el Daniel, que ha conocido en un curso de sueño de la CRS hace unos años atrás. Sí. Nosotros tenemos colaboradores desde entonces. Entonces, ahora me voy a cambiar para inglés. Gracias. I don't need to say good morning and thank you because I said in Spanish. That's all the presents here are Spanish, so I think it was more polite for me to do it. But to talk about research and science, it's kind of a bit difficult for me because even when I'm talking in Portuguese, when I'm talking at my main home with my students, there are some words that I have some difficulties in saying in Portuguese because it's the translation sometimes seems so awkward, so strange that I tend many often to use the English word because it's much easier. So I just like Marta said, so I'm based in Lisbon. I'm basically in between two universities, so I'm between the medical school and between a psychology school. So, but I'm not a psychologist as background, as you can see. So I'm a biologist. I'm a chronobiologist by background, and I'm also a somnologist. So I'm a sleep researcher by the ESRS. And I have been working in sleep and circadian rhythms for a while. I was during many years in one of the main sleep clinics that we have in Portugal, that is from Teresa Paiva, and that's where I got my clinical sleep disorders background. And that was complemented by Professor Till Brunenberg in Munich. That's where I got my branch from the chrono field. And that's why since then, so everything time matters, just like Hannah was saying. So for me, more than what are you doing is at what time are you doing? So, and at the end of my talk, and of course, Anna already made, it's much more easier, my efforts now, because many of the things I'm going to say, she already approached. So it's just like a compliment. I'm going to continue and give you a different perspective. So a more sleep related perspective of what she was wonderfully speaking before me. So, okay, I have my computer here because I tend to speak a lot and I tend to speak many often without any slides. So I just continue talking. So in order for me to be able to keep the track and to see where I am, that's why I have my other computer here so that I can actually know where I am and how many slides I still have to talk. So without further ado, let's start by talking about the properties of circadian rhythms. So what are circadian rhythms and what are their properties? So they basically have an endogenous driven period of approximately 24 hours. But they are not exactly 24 hours. They are slightly more on average, but there are some people that can also have lower, so smaller endogenous periods. But on average, they are 24.2 or 0.4. Okay, that's usually our endogenous period. So the period, it's the length of a cycle. Okay, and it has a genetic origin. So when we say this, it's regulated by genes. So basically we have some genes that we call the clock genes, let's say like that. So basically that's alternate during the day and the night. So during the day, basically clock and BMAL proteins, they come together and then they promote the transcription of PER and CRY genes. And then after the proteins that produces by these genes, PER and CRY, they come together and then they inhibit, basically here, they inhibit the action of the clock and the BMAL, which in turn suppresses. So here you can see the suppression of the production of the PER and CRY. So it's basically a production and a suppression of these genes that basically it happens during the day and the night across the day. And then it's this production and degradation and suppression that basically has this circadian variation. So this daily across the day and night, and it alternates in accordance to day and night production or a suppression of these genes. Basically, these rhythms, they can run even in the absence of external time cues, and that's why we say that they are endogenous, but they entrain with external cues. And the external cue that it's much more relevant, like say like that. So the primary external cue, it's basically light. So light, it's what we call the master Zeitgeber in humans. So Zeitgeber, it's a German name that it's the time giver. That's what means Zeitgeber. And basically it's what happened. It's what helped us to entrain, to synchronize to the 24-hour light dark cycle. Because we have a longer period on average, just like I said before, and we need this light in order to compress our cycle and to maintain it into the 24 hours of the light dark cycle. So, and something that we actually discover, and it was quite recent, if you might know. So usually we tend to think and to have in mind that we have just two photoreceptors, so-called rods and cones. But then by the 20,000 year, we discover an additional photosensitivity cells that are the EPRGCs, that are the responsible for the synchronization of the circadian rhythms. So basically, it's also responsible for the production of the melanopsin. So, and that's actually what produces our melatonin, that it was already spoken before by Anna. So it's basically this light signaling that rules our melatonin production. Okay, and these are the cells. So these are the photosensitive Befrendian ganglion cells, so the PRGCs that were just discovered in the year 2000. So you may see how recent chronobiology field is. It's really, really very a baby, just like a baby when saying science. And many often you tend to hear that we should not be close to blue light. Blue light, it's you shouldn't have blue light at evening, and it's very harmful. It doesn't help you sleeping, and the reason is because these EPRGC, so the peak of their sensitivity, it's actually in this range. So it's 480 nanometers, and it's actually the blue light, let's say like that, spectrum. So that's the peak of the sensitivity for these cells. And what does this mean? Because when we are exposed to these wavelengths, period, so we have a suppression of the production of the melatonin, because we are saying to our brain that it's still day. And since melatonin, many often people tend to call it like the sleep hormone, but it's not really true, because if we think as a whole, as an ecosystem, so nocturnal animals, they also produce melatonin during the night. Although during night, they are active, they are not sleeping. So this is really the night hormone rather than the sleep hormone. Although for diurnal animals, we know that melatonin has an effect, and it has an hypnotic effect because it helps us disconnecting our activation neurons, like that, in a simplistic way. Okay, so it really helps us falling asleep. So all the organisms that are diurnal, but for the nocturnal individuals, animals, let's say like that. So basically it has the opposite effect. So, and that's something that you can make that question, but I don't have an answer. Unfortunately, we still don't have an answer for that. So we don't know why, and that's why sometimes it's very difficult for us to translate research that it's being done in melatonin with rodents, because they are nocturnal and so the mechanisms are slightly different. So the production, it's the same, it's induced, basically it's regulated by the light, but the effect that has in our brains, it's different from nocturnal to diurnal. Okay, so that's why I tend to say that it's the night hormone and not the sleep hormone, because as a biologist, I tend to think as a whole and not only in humans. Although I work with humans, I don't work with rodents. Okay, in my research. Okay, so here I brought you something that it's very important for us, that it's the light phase response curve. So because our body, so our physiology responds to light. And we have this, it seems like complicated, but it's not that complicated, because we tend to turning it simple. And we use this to treat patients or people that are not patients, but that have some problems in synchronizing their rhythms, mainly their sleep-wake rhythm. We use light. So light, it's really very important. Just like Anna was saying, it's amazing, and it's free of cost, and it's outside. And we are very lucky because we have a lot of light, but we tend to stay at home. But a day just like today, that it's quite cloudy, it has much more light intensity outside rather than here indoors with all these lights, artificial light. So it's much better to be outside. It's really good to do it, although we tend not to do it. Okay, so basically we use as a reference our core body temperature minimum that, as Anna was showing you previously, it happens during the night. Okay. And if we expose ourselves to light before that minimum core body temperature, our rhythms tend to delay. So, and when we do this at the evening, so before going to sleep. So when the lights goes out, so the sun goes down, we continue exposing ourselves to light, to artificial light. And that light, if we are exposed to that light, tend to delay our rhythms. By opposition, if we expose ourselves in light in the morning periods, so after our core body temperature minimum, so our rhythms tend to compress. Okay, so to advance. And that's why when we want people to go to sleep earlier, so there's usually we use a combination. So we tend to increase their sleep pressure. That's something that I'm going to talk to you afterwards also. But we also use this circadian signaling. So this light signaling in the morning, so that we can help them compressing their rhythms. And we do that, and we don't really realize that. So in our daily basis, when we are outside, we do that compression. And that's what actually make us being in the 24 hours, because our endogenous period, it's larger than 24. Okay. And actually that was shown, I haven't bring you that slide. Sorry, many slides, many things that I could show you, but there are some beautiful experiments that were made actually in Munich by Professor Jürgen Aschloff at LMU. And so they in the 70s and 80s, when human chronobiology started, so here in Europe, so the place where it starts here in Europe was actually there in Munich by Professor Jürgen Aschloff. And they used the bunkers from the the Second World War, that were inactivated, so they were not being used anymore. But Professor Aschloff thought, okay, but I can use this as a lab. So I can put my students there, so they can be there and their own free living. We are living their food, you know, different times of day, because if we brought the food, I haven't done it, but Till have done it. So Till was one of those students who were giving the food to the students. And actually he was there during the night or during the day randomly, so that they didn't have any time cue, so that they could understand when it was day and night. And they were running freely. And that's where they could actually saw that their period was longer than 24 hours, because after being without any light cue, so the late dark cycle, they tend to go to bed later and wake up later every day, approximately half an hour every day. They had this delay on their rhythms. Okay, but they were sleeping the same average, so their normal amount of sleep, but they were just drifting on their hours. Okay, and that's where we discover that our endogenous rhythms were actually larger than 24 hours in a naturalistic way. Of course, in Harvard, they were already done in some experiments where you actually put them a rhythmic, and we can actually also measure it in lab, so in constant routine protocols. And that could also be already shown. And that's where we discover that the period is slightly larger than the 24 hours. Okay. Okay. So we have the light, and light, it's absolutely fundamental. And we both already talked about that. And it's really something that it's super, super important. And it's really, of course, and people tend to take pills. Okay. But we have some other synchronizers that can help synchronize our periphery. So because we have the central clock, just like Annette spoke before, that it's in the suprachiasmatic nucleus, that it's the maestro of all the orchestra. But we also, we have all the other periphery, all the other clocks in the periphery that actually are synchronized. They have their own rhythm, but they also have a connection to the nucleus, the suprachiasmatic nucleus. And so if we tend to have this periphery, the synchronize, so the peripheral clocks that we may say that we can have, so how can we disrupt them? So, or how can we activate them in the right place or in the wrong place? Let's say like that. So by doing exercise, by feeding. So we have been seeing over the recent years that feeding pattern, it's actually a very strong synchronizer. Okay. So for you to eat in a proper time, especially outside your biological night, and I'm going to tell you later on what is the biological night and the biological day. But basically, when we do some behaviors that are out of our naturally way of being happening, just like sleeping during the day or being feeding during the night, so you are actually giving wrong cues to your rhythms, to your body, to your physiology, that it's a normal day and night, active during the day, inactive during the night, and you are giving wrong cues. And that's when we do this wrong behaviors, we are actually giving wrong cues, and we start to misalign our endogenous rhythms. And that's when we do that, then we tend to progress for illness. Okay. Especially if you do that continuously. And actually, we have been seeing this in shift workers, because their main problem is that. So they are working and being active during the night. So, and that's where it's your biological night. So during your biological night, you shouldn't be working or feeding. And that's why they usually have a higher vulnerability to some diseases, namely the cardiometabolic disorders, also mood disorders. They are much more vulnerable to develop those kinds of health issues, let's say like that. Okay, basically our circadian rhythms, they modulate our physiology from metabolism to behavior. And one fundamental behavioral circadian rhythm is actually the sleep-wake cycle. It's the one that we all can see, because we have, okay, our melatonin, it's running, our cortisol, our core body temperature, but we need to measure it in order to know the amounts that we are having at what time of the day. But the sleep-wake cycle, it's the only one that we can actually see. We can see when someone is sleeping, and we can see when someone is awake, okay? And how does this happen? So how is the sleep-wake regulation? Okay, there's mainly two processes. And one of the processes I was already talking about it. That's the one where I started. That it's actually is a circadian process. So it is the circadian drive for being awake or for being sleeping. So there are signalings. So internal signalings or external can also give cues that activate your internal signalings, just like the light with the melatonin. Okay, so you need those environmental cues in combination with your endogenous. So we are talking now about the endogenous rhythms, the ones that I start by talking before. That is the process C. So circadian drive for arousal, process C. We also have another process that it's a process S, that is the homeostatic sleep drive. So it's your sleep pressure. And basically, during a 24-hour day, this is what you can have on average. For someone that it's an early type and wake ups at 7, this is what we have here represented. So your homeostatic sleep drive starts being built at the time you wake up. And that's why Anna was saying very nicely, and I applauded when she said that people tend to evaluate cognitive function indifferently, across the day or whatever. It doesn't matter. But for me, it matters everything. And the first thing that I ask, or that I ask for people that work with me to ask, it's actually at what time they wake. So at what time they wake and how much was the amount of sleep that they had the day before, because they might be sleep deprived and they might also be compromising that what we are actually seeing. And most of all, how is their usual sleep wake behavior when they don't have an alarm clock? Because imagine if you wake someone, so you establish a cognitive assessment for someone at 9 because it's when you have that slot. But that person it's through late type. So in order to be that at the appointment at 9, they need to woke up at least 2 or 3 hours before. And so he's totally sleep deprived, number one, because he needed to put an alarm clock to wake up earlier. And he's performing probably still in their biological night, because if it's someone that it's really a late type at 9, it's might be still their biological night. We don't know. Okay, so that's why it's so important to know and to have a broader perspective, because sometimes this is really relevant. And actually, I raised this problem at the medical school, at the psychology department there, because they were doing assessments. This was the case. And sometimes when you have a suspicious of cognitive deficit, that for some professions, it might be basically something that can not allow you to work. There are some assessments that might be done, and that where they can punctuate as very slow reaction times, some deficit memory, and all those cognitive assessments that might be impaired just because they are sleep deprived and they are doing them at the wrong time. Okay. And that's something that we really need to have in mind. And that's really, really important when we do those kinds of judgments, let's say like that. Okay. So basically, in what the rule here for the sleep wake regulation is that homeostatic sleep drive, it's built after wake, just like the circadian. If you are circadian aligned, if you are aligned for your wake up, okay, they both go running across the day. Although the homeostatic sleep drive, it just goes down with the sleep period. If you don't have this sleep period, so these homeostatic sleep drives continue to grow. And it just goes down when you have a sleep period. By opposition, your circadian process, so the process C, it's circling beautifully across the day. And that's why when you are a shift worker and you are working during the night and you return here to go to sleep. So imagine, so your sleep drive could continues here and it's really high. And then you go to home. You can even start sleeping, okay, because you are super sleep deprived. So your sleep pressure is really high when you arrive home. But then after a few hours, then after if you start sleeping, your sleep pressure start decrease and decrease very hardly, as you can see, as soon as you start sleeping. So what happened is that more or less 4 hours after, so you have a huge sleep, awakening signaling. So your process C, it's still super big, but your sleep pressure, it's not that big anymore because you are seeing here. Okay, so it's already below your process C. Also, and that's why many often shift workers complain that during the day they can't sleep much more than the 4 hours or 5 hours. Okay, so they sleep less on average during the day because they need to struggle. So they have this internal physiological struggle that when their sleep pressure is too high, they can fall asleep, but then afterwards, a few hours after, their circadian drive for being awake, it's higher than the sleep pressure, and then they tend to wake up. Okay, so that's why it's so difficult for them to be able to rest properly. Okay, but okay, so we spoke about circadian rhythms. We spoke about already some sleep already. We will return to sleep later on, but now I'm going to bring another issue that Anna already started talking about. There are the individual differences. Okay, we all have different temporal phenotypes. And what does this mean? Actually, we tend to call them chronotypes, that we can also call them circadian types, just like typology. Yes. Okay. But I agree with both. I agree with both. Okay. I think this is a smaller one, but it's basically I'm pretty right. I think you are pretty right in what you were saying. So what's a chronotype? Basically, it's a preferred timing for certain activities, just like sleeping or being active. So, this is what we tend to say. But how can we assess chronotype? Okay, that's something that many often people ask. So, how can we assess it? So, we have objective phase measures. So, we have actimetry, when you can actually have activity, we can have light, we can have temperature. Those are the signals that we usually use and are quite useful, just like Anna showed very beautifully, those temperature curves that it's really, really nice. And you can actually, I tend to use the temperature sensor for taking naps and taking sleep. So the algorithm, it's much improved when you usually add the temperature channel and not just focused on the activity, just like, regularly people use. I think it's increases really the sensitivity. And oops, go down before. Okay. So this is an actimeter, just like you can see. So these are the ones that I usually use. So they have a contact, they have the activity, they have lights for RGB. So why it's interesting? Because I can have light via spectrum. So I can know the spectrum of light that people are actually exposed. And I can even give recommendations for people, because I can see if they are exposed to a very intense light source of blue light, not just the total light. So, and I can just say, okay, try to reduce the amount of light that you have in your bedroom, because it's really pretty much high. And actually, there's some recent studies that some colleagues have done in Chicago from the Phillies group, where they saw that the small light, so just like a presence light, the ones that we have in our room sometimes, that amount of light can actually disturb your sleep. So people tend to think that it's so small, and our eyelids are, our eyes are closed, so the light will not come in. It comes in, okay? And that was shown that even a small amount of light during the night can disrupt your sleep. That's why we need to have black nights, let's say like that. So nights without light, and days with plenty of light, because we need to increase our rhythms. Our endogenous rhythms need to be increased. So this signaling, this light signaling needs to be really discrepant from day to night, so that we can give the right inputs to our brain so that he can actually work properly. And that's what we do in clinic. So in patients with circadian rhythm sleep-wake disorders, we tend to treat them with light. So with light therapy, with phototherapy. And people with uh, many different disorders, just like and some that we saw in more elderly, just because we have, and I will show you later on that also, we have a decrease in the amplitude rhythms. We tend to have a more disrupted sleep. Okay, so it's very common to see people with irregular sleep-wake pattern, even more common with people with neuropsychiatric disorders, but neurodegenerative disorders, just like Alzheimer's, Parkinson's disease. So many often these people tend to have this arrhythmicity, okay? And what we do then, it's actually we increase the rhythms with phototherapy, and the phototherapy, it's not just giving them light, it's also removing the light that they have in an appropriate time of the day. So because we want to increase this signaling with also, regular feeding patterns. It's also really important. So light exposure, regular feeding patterns. So that's something that can actually help in signaling. How do you think that's, and also supplementing with melatonin, okay, at the right time. So slow release melatonin, it's also something that it's also given to these people, okay? It's a combination. But the thing is, it improves a lot. Okay, so here it's an actigraphy, just like you can see it's how this is temperature, this is sleep. So this person has plenty of actigraphy of activity during the night. So it's just for you as an example. So this is an off wrist here. You can see because I have a drop in the temperature. This is non-physiologic. Okay, so in here we need to say that this is an off wrist, and so it's something that we need to clean, let's say like that, in our actigraphy. So we only need, the first thing that we do, it's actually to clean and to remove all the off wrists, because otherwise, if you want to do 24-hour metrics, it's going to mess up all your data. So it's something that you need to treat a lot in the beginning. So this is something that you can see. So it's a double plotted graph. Why do we use this? So in sleep and circadian rhythms, usually we use these double plotted graphs because we need to have the day and the night. And so here in yellow, it's the day. So it's the photo period. Usually we put the photo period as a background, and then we show the activity and the inactivity, and we can see if the activity it's in during the photo period or if it's during the night period. So this person, it's pretty much into the photo period. Okay, so it has a synchronized, let's say like that, sleep-wake behavior. Okay, but that's why we use this kind of tools so that we can actually see the people's behavior. So this is it's something that we can also add, that it's a diary, because we always use also diaries to complement with actigraphy. Okay, so this is the melatonin. So it's something that we also use, and in the clinic and research, we tend to use it. You can measure it in saliva, you can measure it in blood, urine, the metabolite in the urine, just like Anna was saying. So usually in the clinic, the more common it's saliva because it's non-intrusive. We have a protocol that it's established according to their habitual sleep time. And according to that, then we establish all the time points that we need to have. We need to have at least a minimum of 5 time points. That's the minimum that we use. But when our people that might have, they're pretty much delayed, we tend to increase it. Although what we have seen in not only in delayed sleep-wake people, but also in the general population, is that this difference that we call the phase angle. So the phase angle, it's basically the distance between the melatonin production and the time you fall asleep. This is on average 2 hours. Okay, this is the phase angle. It's on average 2 hours, but it can range a lot. So this phase angle can go as far as 5.5 hours before sleep time and until 1 hour after. Okay, and this brings us some difficulties when we try to measure it. And that's why sometimes it's tricky, okay? We try to do it, we continue to do it because it's still the endogenous phase marker, but it's tricky. So many groups have trying to establish some new tools in order to calculate our endogenous phase, our endogenous biological night, let's say like that, because that it's so it's going one step behind. So the biological night, it's basically the period comprehended by the beginning of the melatonin production and the end of that production. So it's this period, and all the rest we call the biological day. Okay, so it's basically the melatonin production that we call the biological night. And it's this one that we should avoid by doing, by eating, doing exercise, and all those wrong things that are dedicated to night. We should be sleeping on that period mainly. Okay, that's the behavior that we should do. And just like I was saying, since in practice, so in general daily life, sometimes it's difficult because we have a lot of difficulties. It needs to be in dim light because light will influence the production. There are some techniques. So in Charité, and so in Berlin, in the Charité, people are developing a new methods based on the variation of the clock genes. So I showed you that these clock genes, their production changes across the 24-hour day. So some of them are high during the day and others are low during the day and higher during the night. And so according to that variation that we do, so they are establishing an algorithm based on the variation of the production of those clock genes. And people are trying to establish new methods to evaluate that endogenous biological night. And also with metabolomics. So metabolomics also have a variation, a circadian variation. And together with the Surrey group and also in Groningen, people are developing new methods based on metabolomics variation, because we are trying to develop new tools that we can use rather than the melatonin. Although melatonin continues to be the gold standard, let's say like that. Okay, so, and then we have the subjective measures. Then people tend to disregard because they are subjective, but they are super important. They are really, really super important. So the diaries are very, very good tools that we can use. Usually I like, it depends on what you want to evaluate and what you want to know, but many often the visual sleep activity graphic diary, it's very useful because people can see visually when they are sleeping and waking, and when they are having coffee, because they can just put a C, or sometimes they can tell us when they're taking their medication, and then we can actually try to make a connection, because medication does change a lot, okay, and it can influences a lot on your sleep. And that's something that it's actually one of the big challenges that people have in the clinic, because when we come to the clinic complaining that they sleep badly, they already went to several physicians that gave them several drugs, and then they tend to even combine them all, and then it's an iatrogenic problem that many often physicians tend to need to deal with. And we need to know that for insomnia, so the first line treatment for insomnia, it's non-drug. Okay, it's non-pharmacological. It's a non-pharmacological approach, but people tend to go to the slower way and pick the first drug that they can have. So, but that's a different issue that could, be another different talk. Okay, then we have questionnaires. So we have the morning as evening as questionnaire, just like Anna presented before, that we can say is a psychological trait. So it's based on different questions, and we ask people for their preference to be doing exercise, to be doing an exam and stuff like that. So it's a combination of different questions. And then we have the Munich chronotype questionnaire, that it's tilted to say that it's more like a biological trait. It's more like the phase of entrainment. It's more like the behavior of the person, okay? But people sometimes, they tend to ask me, which one is better? And I say, they are both good, okay? They give me different stuff. So one give me one thing, it's how do they, consider themselves? So how do they, sometimes they even say that how they would like to be rather than what they actually do. And namely, in the late sleep-wake phase patients that we see in sleep clinics, many often we see a mismatch on these two. So they tend to say that they're slightly late, let's say like that. But then when you see their behavior, they are extremely late. They can go to bed at 6 a.m. and wake up at 11. So, but although they are just slightly late. Okay. And something that we also see, it's a difference according to the age groups. So people that are more young, so adolescents and young adults, they tend to consider themselves as slightly late, although being very late also, because, and why do you think this happens? It's because, all of them are late. So so the people tend to consider themselves as according to their peers. And if all them are late, okay, I'm not that late. Come on. I just go at 2. My colleague goes at 4, so I'm not that late. Okay, so that's why. But in general, if you put them all in the same box with people from different ages, of course, that people it's super late. Going to bed at 2, it's late. Okay, but he doesn't consider himself as late because their peers are later than he is. Okay, so it's something that it's different, and we need to look at these people one by one and look to all the different pieces in order to complete the puzzle. Because if we tend to look just for one side of the story, we might have a different, a wrong perspective of the person that we have, because we have these changes. Okay, and we know them. We have been studying them all, over the years. So I'm going to show you how is the Munich chronotype questionnaire, because people many often don't know. So because the MEQ, it's much more common. So the Munich chronotype questionnaire, it's a questionnaire where when we ask people at what time you go to bed, at what time you turn the lights off, because you can go to bed and being awake. Okay. It's not because you are in bed that you are sleeping. And many often people ask, at what time are you going to bed? And then you consider that that's sleep. That's not true. You can stay at least 1 or 2 hours there, because I just like to be there reading my book. Okay. So you need to have these things. And actually, nowadays, we even have a smaller questionnaire that it's actually the micro MCTQ, that it's the shortest version that we could actually build on and validate. And basically, we ask people at what time you fall asleep and what time you wake up. Okay. Okay. It's the more simplistic, but it's the one that it's more accurate to have your sleep out. So that's what we got. So we ask this for work days and for free days. And the metric that we use to estimate chronotype or phase of entrainment, it's actually the midpoint of sleep. So we have this MSFSC, that it's mid sleep on free days. That's the one we use, sleep corrected. And we use the free days if they are not using an alarm clock, because if they use an alarm clock, then they are not waking up by themselves. They're just waking with your alarm clock. So it's not really their internal timing. And that's why we have that limitation for the MCDQ on that sense, but we assume that. And another metric that we have that we use for as a proxy for circadian misalignment, it's actually the social jet lag that I'm going to talk a little bit later on, but it's a proxy for circadian misalignments. But it's something really, really simple. It's just calculating the difference between the midpoint of sleep on free days minus the midpoint of sleep on work days, and then you have a number. And that number, it's actually the mismatch between work days and free days. Okay, people tend to say that social jet lag, it's the same as sleep deprivation, and it's not true. Okay, so you might have just this mismatch and have the same amount of sleep. It's just what you have here represented. You have the same amount of sleep, but you are just sleeping in a different phase. It's the phase that we are calculating. Although in real life, what we see is many often these people also have sleep deprivation. So they sleep less during the work days because they have the alarm clock. And when they go to free days, they tend to sleep more because they have their sleep time, the one they need, plus an additional amount of sleep because they tend to have what we call sleep rebound. Okay. They try to compensate. And people many often ask me, okay, do they compensate? They really compensate? I might say, yes, but not totally. Okay. There's also always a sleep debt that it stays there. And how can I say this to you? There are many studies. Of course, again, I couldn't bring them all, but we know that when we sleep deprived people, when you do studies with total sleep deprivation, people return to their baseline sleep at the third day. Okay, so on the first day, they compensate deep sleep. It's the first stage that you tend to have a rebound, and actually it's a marker of sleep deprivation. It's actually an increase in deep sleep after at the next day. And in the second day, you still have a small rebound. We can still see a small increase, but we increase in REM sleep. And at the third day, they can actually have a normal sleep when they have before. So that's why, if we think about a normal week, we only have two off days. So we never can compensate. Okay. That's a take home message, is trying to sleep the amount of sleep that you need during the work days, because it's difficult for you to compensate. Okay. And chronotypes are not static. They do change across life. Okay. When we reach adolescence, something that we see, it's actually a lateness. So they tend to become later. And we used to say that chronotype, we can say that it's a marker of adult life. Because if we see that, so they end their sexual maturation, and we know about that. So women tend to end it earlier than men. So women, their chronotype turning, let's say like that, it's actually the end of the sexual maturation. It's around 19, and for males, it's around 21 on average. Okay, and we see that on chronotypes. And then we have again a change that it's actually here that we can easily see what this is. Okay, this is of course menopause. And actually the protection that women have when they were still, sexually active or whatever, when you have your decrease in estrogens, what we see here, it's actually a reverse. So women tend to become later and men become earlier. And there's no study still showing this clearly, because it needs to be done with a longitudinal study. There's no longitudinal study showing this, but everything points to this relationship with the decrease in the hormonal levels of estrogens in women. So what makes a chronotype are three things mainly. So it's a genetic predisposition, age, and light exposure. So these are the three things that actually can play the role. So here is the chronotype distribution. So this is the Munich chronotype distribution. So for our large data sets, that it has approximately 280,000 people from all over the world. Of course, much more people in Germany, but we also have some Spanish there, okay? And we can see that, just like Anna was saying, so you have the small amount, they are extremely early, a small amount, they're more later than early, let's say like that. But the largest amount, it's actually in between. So are the people that are here. So here is the mid-sleep point of unrestricted sleep. So the one without an alarm clock. And here are the representation of the sleep timings. So for an 8 hour, assuming 8 hours of sleep, so people on average sleep much more around 11 and 7 or midnight and 8. So these are, the majority. And if you think, it's according to the light dark cycle. But also chronotype change across time zones. And you here in Spain, you do have a big problem because you are in Central European time zone where you shouldn't be there. So the best for you would be at least the time zone that we have in Portugal. Okay, because you have a really mismatch. And you can see here, because when you go much west in the time zone, people tend to be more late. And that's because it's when you have, we as human beings and all the humans and all the species, they tend to follow the light, follow the sun. And if you think as more west you are from your time zone, the sun is going down later. And if you have the sun later, of course, you're going to sleep also later because you have more light during your expanding zone. Remember the, phase response curve that I said? That's a problem that you have. That's why you tend to be so late. It's not that you are that late. Come on, you're just following your sun. Okay. And if we correct for that difference between solar time and clock time, you have a huge difference. You have a huge mismatch. During the daylight saving time, you go beyond 2 hours of difference. So it's really something that we need to change. Okay. So this is a representation from the Munich chronotype questionnaire, where you can beautifully see that people going more west, from east to west, the chronotypes tend to be later. Here is the status quo with clock time versus sun time, where you can actually see. So this is standard time. Here is Spain. You have already naturally, even in let's say, winter and summer, because that's what people wrongly say. Because when you think about, okay, winter, I don't like to be in winter. In summer, it's much better. It has much more light, but that's the seasonal change. Okay, that's something that is there. We are just changing the clock time, the one that we have in our wrist. Actually, I don't, but yeah, that's the one. Okay. And naturally, we already have, you see that you should be here because behind you have solar time, in front you have the clock time, and you have this mismatch. So we are also slightly off, but not as off as you are, definitely. And when you add the daylight saving time, you can see the difference. So you should be here according to your solar time, and you are here. So you can see how far from your sun you are. It's really, really a problem, okay? Because we do follow the light. So how many clocks do we have? That's something that people tend to ask. So we have the sun clock, the sun, that it's truly important. We have our body clocks that we already spoke here, and we have the social clocks that are conventional times that we need to put in our lives so that we can go to work and do our duty affairs. So, okay. And the problem is that this one here synchronized with this one, and this one, it's actually making, a stone in the thing. Okay. So what happens when our social internal time and social clock are misaligned? So what's happened? So that's what we see. So we have a difference. That's why I was saying that social jet lag, it's actually the difference. But what we see in our lives, it's usually during the work days, people tend to sleep less. Okay. And then off days, people tend to sleep more. But when you aged, this compensation tends to be not as easy as it was when you are younger. Okay, so that's something that we also need to have in our minds. When we are smaller, younger, let's say like that, it's easier for us to sleep more. But then it's more difficult. So here you have the amount of time that a teenager or a school age children should be sleeping. And I was talking about this yesterday, if you remember. So it should be for a teenager between 8 and 10. How many of our teenagers are actually sleeping this amount? Almost none. Okay, that's what we see. And of course, that brings us a problem. So they do have a lot of social jet lag because they have an endogenous later chronotype. They need to go to school. Okay, so they have always this different phase of sleeping during work days and free days. That's what we see. So this is what representation. So what is social jet lag? So this is a difference. This is basically midpoint of work days, mid school days. Let's put like that. Midpoint of school days, midpoint of free days, and you can see this, change, permanent change. And this is from the unichronotype database. And you can see that's only 13% of the whole sample does not have any kind of social jet lag. Okay, 13%. It's a very few amount. So in general, majority of people do have social jet lag. And you can see that the amount of social jet lag, it's overlaps with the chronotype distribution. Of course, people that are more late, they tend to have more social jet lag because they are much more misaligned. Okay, what we know. So it's published. So people with more social jet lag tend to be more smokers, tend to consume more alcohol, caffeine, or the stimulants are associated to this type of behavior. And also obesity. So obesity, of course, it's also associated. And it's basically, the problems that I was talking in the beginning about the health, the sleep health, the relationship between sleep and health. It's actually quite explained by these types of behaviors and circadian misalignment. And what about adolescent sleep and circadian rhythms? So what happens with the kids? So basically, this is a sleep-wake regulation that I brought before. So you remember process S, process C. How does this work? So what I can say it's that for children, so here you have tenor 1 and 2 and tenor 5, that it's the latest status of adolescence, so almost reaching the adulthood, let's say like that. And you can see this is the slow wave activity. So they have, and I told you before that slow wave activity, it's a marker of sleep pressure. So as much sleep wake activity you have, as higher is your sleep drive. Okay, let's put it like that. And what we see in these children is that they have, on average, okay, normal children without sleep deprivation, they have a lower sleep wake activity. So they tend to have more sleep. Let's put it like that. So if you think about the phases of sleep, so of course children have more sleep wake, deep sleep, okay, but they have more during the day. So across the day, it's much more difficult for them to build this sleep pressure. Okay, they took much more time to have a high sleep pressure in order to fall asleep than an adult. So it's much more difficult for them to be able to be sleepy. Let's put it like that. That's why they can, and they stay up until so late, because their sleep pressure, it's difficult for being built. And if they are activated all the time with games and stuff, of course, it's much more engaging. That's why it's so difficult for them to fall asleep. And with the combination of that delayed phase, endogenous phase of rhythms, because biological rhythms are not static, they change across life. Okay, here you have a representation of the 3 rhythms. So you have melatonin, cortisol, and core body temperature. And I would like you to focus on this. So this is childhood. And this is the acro phase of melatonin production, because that's the one I want you to look at. Then you see what happens when you got adolescence. So it becomes much more late. Okay. That's what we see. It's endogenous. Okay. And then you have adulthood, that when it goes back again. And of course, that's another thing that Anna spoke also, that it's the amplitude decrease. We see that. So we see that in later life. And that's why it's so difficult for people more aged to be sleep and being awake. So because you have this decrease endogenous, it's regarding to aging. It's a normal process, physiological process that actually happens, but decrease your amplitude rhythms. So what are the evidence for mechanisms of lateness in adolescence? Okay, so you have an increase in the endogenous period. Okay, so usually our endogenous period, I told you that it's larger than 24 hours. It is on average larger than 24 hours, but we have seen that in adolescents, sometimes their endogenous period, they tend to be larger also. And that's something that actually expands their days. Okay, that's why they become also have that later endogenous period. So this was shown here. You see that you have that increase in the endogenous period when you are in pubertal timing. You see, so this is an adult, and this is actually adolescent. And then, so adults 24.12, and here you have adolescents with 24.27, so it's slightly larger. Then there is another study actually also showing some evidence for light. So the sensitivity for light in the evening apparently also seems to be higher in this group. So, well, just like I used to say, if for an adult to be close to a light source of light, so to a bright light intensity at the evening, it's bad. For adolescents, it's even worse because they are more sensitive to light. So they respond much more. So there are studies done with popularimetry showing that. Okay, you can see that. I put here the morning with question marks because there are still not studies assessing morning sensitivity, but for evening sensitivity, there are some studies showing that. Actually, there's a very recent study. It's still in bioarchives. I don't know. I still haven't found the paper really published, but where they can actually show for different wavelengths for red and blue, and then the area under the curve. So the suppression, let's say like that we have according to the spectrum. And if we have adolescents or children, so younger children, they're still haven't reached adolescence. That's why they are much more earlier. And then it's when they reach adolescence that they can actually have this increase in light sensitivity. That's why we think that it's really related to hormonal production and to sexual maturation. So it's something really physiological and endogenous that we have been seeing in several studies, but we need to know that, and in order to intervene. So here it's for you to see that it's not only in humans, okay? This delay in pubertal status, so this delay in their phase, sleep-wake phase, is present in other species, not only in humans, in Homo sapiens, let's say like that, okay? We also have monkeys and mice and other species where we also can actually see this delay during pubertal status, okay? So this is what we see. So we have a delay in their sleep timing during adolescence. So we have a shift in the phase, not about the duration, but actually the phase. It's physiologic, okay? No doubt it is physiologic. Although people tend to say that they are lazy and so on, it's not that. It's really physiologic. So this is a representation of the two-process model where you can actually see, so here in dash, you have the adolescents where you can actually see that delay in the circadian phase. And here you have a decrease in the sleep pressure. So this is a sleep pressure process S, and you see that it's lower when you're an adolescent. So that's why it's so difficult for them to fall asleep. It's a combination of all. So what are the exposures to poor light exposure? I'm going to pass very, because I think I might be running out of time. I don't know how much time I have, but probably I have run it already. So during during the pandemics, we done a study during the lockdown. So because we thought that everyone are at home. This is a lab. Come on, we don't need to bring people to lab. They need to stay at home. So there's mandatory. So we, across many countries, we gather some data, including Portugal and Spain and other countries, and we could see that. So what we were expecting, because in theory we know, and Ashlaf showed that if we have our period, it's larger than the 24 hours, and without our synchronizer, we become later, and that's actually what we saw. So during this study, during the lockdown, we all get late. And if you can remember, most likely you can remember about that. We all get late during the lockdown. We got late. We had less social jet lag because the one of us that we were working from home, so we didn't have any commuting time. So it was really an add-on for late types for being working at home, I'd say like that. Although they become much later because they didn't have their daylight outside. Okay. We also show that daylight and well-being during confinement. And so the people that had fewer lights were the ones with reporting worse well-being, because light, it's good for at many levels. Okay. Even this sensation of feeling well. Okay. And just like Anna was saying, light, it's a very effective treatment for mood disorders, and it's much more effective many often than some drugs. And the combination of both, it's even much better. So that's why in the clinic, people should add both. So not only the drugs, but also light, because light is really good and we have it for free. That's a good advantage for Portuguese and Spanish and Italian. So the southern countries are our lucky bastards because we have light. Okay. And in adolescents, what happened? The same, but even more, because they are late. Okay. So they do saw that. And then, is it possible for you to synchronize with your social clock? Okay. That was a question that we have. And I have a large sample with people with delayed sleep-wake phase. I look at them. We saw, I'm going to pass very, very, very quick. The only thing that I want to show, but the graph, it's not there. But let's focus here. Okay, this is the dim light melatonin onset for local time. And then I correct them for solar time. And you can see that the ST, they are later. But when you correct, okay, then you have the timing of the melatonin production is the same. What does this show is that we really follow the light. We don't follow the clock watch. Okay. So this is something that we done because of the daylight changings and daylight saving time and so on. We published in a Journal of Pineal Research because we really wanted to show this, okay, with patients. And the consequences are short sleep deprivation. Another small remark that I would like to leave you here is that the relationship with sleep deprivation and performance. It's something that it's really important. And for us students at schools, it's really important. So this is a study done by some fellows in the US by Hans van Dongen group, as far as I remember. And it was a study where they put people sleeping so they had a sleep window. So absence of sleep, total sleep deprivation. And you can see here that they just run it for 2-3 years maximum, and then they finish the trial, can't continue. And then for the others, you have 4 hours time in bed, 6 hours time in bed, and 8 hours time in bed. And you can see, so these are the days of sleep restriction. And you can see that it's progressively being worse across day. So this is assessing attention. So this is a psychomotor vigilant task. It's a test of vigilance. And you can see that people, so the deficit, it's accumulating. And also the performance, it's being decrementally across days. But if you look at this side of the window, that it's the same study, okay? So this is another thing. So this is how sleepy they feel. So this is a sleepiness state. Okay. And you can see that, of course, here, it's a totally match. Whoa. Okay. Uh, Undoubtedly, they are super sleepy. But then here, if you look at how they feel, it's not, you don't have an overlap. So what we see is that people tend to have this disconnection of the objective sleepiness and the subjective sleepiness. And this tend to be, that's why we see in patients that have, imagine sleep apnea, one of the features is that they have daytime sleepiness. The ones that are worse, so the more severe cases, they tend not to complain about sleepiness. They just realize that they are sleepy when they put them a CPAP, and then they realize that they are sleeping badly. But they have a mismatch, cognitive mismatch between what is their actual sleepiness or the performance decrement and the way they feel. Okay. And this is where the problems come up. So this is where actually the accidents come, because people they leave that they lost this awareness. Okay. And okay, challenges faced by youth. This is the final one. A lot of things Anna already spoke, but this is the perfect storm model by Professor Mary Circadian, that it's the person in sleep that have actually, studied her entire life, sleep in adolescents and children. And basically, it's a combination of many, many things. So we have a circadian phase delay. We do have a slow rise of sleep pressure. So the sleep pressure, it's much difficult to rise. Then it gives you a delay in the bioregulatory pressure and the psychosocial pressure. They become autonomy, because they go to bed by their own. At least we hope. Many often we need to go there the same way, but they start to be more autonomous. You have an academic pressure also, namely in the more older ones, let's say. You have the screen time and social networking, that it's part of their life, but it's also something that we need to add here. And then we have the school start times that many often are quite early in the morning. And this was made in the US. They had, when she done and start doing this, you had people going to school at 7. That was really a huge problem that they had. Nowadays, it's not as that. It's 8.5. But okay, this is still a problem. So late to bed, early to rise, short sleep. That's what we see in these adolescents. And that's what I wanted to bring it to you.
No, yo creo que tenemos claro un poco cuál es el diagnóstico, ¿no? Sobre todo la gente que estamos ya metidos un poco en faena con esto. Pero sí que es cierto que a veces ¿no? Me da la sensación de que a veces se busca un poco la solución de los problemas, o I should ask you in English, maybe. I don't know. Sometimes we are like thinking that, okay, this is like this, but let's solve it individually. No? Let's see whether we can give them melatonin, whether they should do, no? And it's very difficult to convince people that the change have to come from the structural change. No? And I think I'm also in the book by Ronenberg, the Internal Time, he also talks about the efforts he has done to try to change schedules in Germany and how difficult was this change. No? But I think it's also connected to some of the discussion we had yesterday. No, I think we trying to mitigate the consequence of the bad alignment in individuals, make them responsible for you should not have friends, you should not use social networks, you should be going to bed earlier. No, well, I think Anna was also asking before. No, I think but kids have to go to school later. They have maybe to have some activities in the morning outdoors. They should have this chance to go to the school walking calmly and being this half an hour, what Anna was suggesting before, outdoors by walking to the school in the morning, getting their half an hour of sun in the eyes before they enter a building. And we are neglecting this. No, in Valencia here, the kids in high school, they are entering the school in some periods of the course during the night. during the night they enter in the school. So there is no even a real chance to get any bite of sun in the eyes before they enter. So yeah, I don't know whether this is a question or
Hay una pregunta. ¿Es posible forzar el reloj endógeno genético a ajustarlo al social para reducir o eliminar el jet lag social?
Podemos intentar a forzarlo, pero tenemos que pensar, tener en nuestra cabeza que es un esfuerzo, estás a ir contra tu genética, siempre, ¿ok? Es lo que hacemos a los pacientes con retraso de fase, es que los damos luz por la mañana, le damos melatonin por la noche, los quitamos la luz por la noche, los decimos tienes que cenar más temprano, en todas las cosas que los pueden ayudar a sincronizar. Pero lo que lo sabemos es que, imagina, tiene que haber un compromiso muy grande para se quedar en este ritmo, porque se va a una noche para la disco y te vas a dormir por la mañana, te vas todo atrás. Tienes que pensar nuevamente. Es difícil. Entonces, algo que tenemos que hacer es algo que como sé por hacer en la clínica de Teresa Paiva, es que, muchas gracias, Diego. Ha dicho que se encanta mi portuñol. Es que yo no soy clinista, yo no soy médica ni tampoco psicóloga. Yo soy investigadora de base. Y lo que yo hacía en la clínica de medicina del sueño era a explicar la fisiología a los pacientes y los explicando, es decir, lo que ha pasado, tienes un background genético que está a condicionarla, pero si haces esto, y si lo cumplas, te vas a mejorar. Es algo que lo hacemos despacito, media hora, una hora máximo por día, que te vas a cambiar el ritmo, porque si lo haces de una vez, no funciona. Entonces es una combinación. Tienes que decir a las personas, ok, van a hacer ese cambio de fase despacito. Tienes que saber lo que está pasando y lo que tienes que hacer. Entonces, es lo mejor que lo podemos hacer. Tiene que haber un compromiso muy grande de las personas. Es por eso cuando me preguntan, ¿qué vamos a hacer con los adolescentes? Lo que digo es lo que hago, que voy muchas veces a las escuelas, por nada quiero, pero me encanta hacerlo porque sé que soy a hacer la diferencia. Es que voy a explicar de una forma simple para los niños lo que está pasando con ellos, y que es fisiológico, y lo que les puede hacer para mejorar, y cuáles son las consecuencias cuando no lo hacen, cuando que se quedan a jugar ante 4, 5, 6 de la mañana. Muchas veces lo digo, lo sé que es muy bueno para nosotros, pero tiene que pensar cuáles son las consecuencias cuando lo hacen. Entonces, educación es lo mejor. Porque con adolescente, tengo dos, una un poquito más, pero si lo dices, no lo haces, es cuando lo hacen. Entonces, lo mejor es lo de explicar, es decir, lo que está a pasar y lo que puede hacer. Esperar que alguno te puede oír y que hace la mudanza. Pero tiene que, eso para decir, tiene que salir de ellos. De otra forma, no hay hacer nada. Peor, peor.
A ver, que a nivel social, a colación de lo de Daniel, yo creo que hay que tomar iniciativas en beneficio de ajustarnos a la situación que es fisiológica. Yo no quiero llamarla genética, porque no es completamente genética, porque cambia, no es determinista. Y a la vez también es verdad que en estos casos extremos que acaben siendo patología, hay que hacer abordaje individualizado, ciertamente. No podemos decir, mira, es fisiológico. A los padres les hemos de enseñar a no decir gandul y ya está bien, pero sí que hay que estar en un punto medio. En un punto medio que tienen actividades nocturnas, manejar actividades nocturnas, un ocio saludable, y no salir a hacer el botellón. Y esto se puede manejar también a nivel de ayuntamientos, que no se hacen muy poquitos. Bueno, hay que hacer muchísimo trabajo. Y en cuanto al cronotipo o tipología circadiana, no hay solo el MEC y el IMSITIQ, pero es que sobre todo el MEC, si lo comparas, entonces dices, claro, es que pide deporte, pero hay una versión reducida que extrajo solo matutinidad, vespertinidad, de las 3 dimensiones que mide el MEC. Y el MEC lo que pasa es que se está usando mal, lo cual quizá a los de los otros cuestionarios ya les va bien. Se pasa por internet, se piden intervalos horarios, hay una escala perfecta y te marcan la hora de levantarse, la hora de acostarse, la hora en que se encuentran mejor. Lo que no pide es días festivos, por lo tanto el jet lag social te queda, que se puede añadir esa información, porque es que el reducido son 5 ítems. Estoy absolutamente de acuerdo en que compararse con los demás. Ahora hemos hecho un mini paper en Chronobiology International con Vincenzo y Lorenzo. Y dices, esto de compararse, ni yo me sé comparar. ¿Qué hacen los demás? Me parece, ¿no? Pero con datos objetivos, pues a mí el RMEC me parece muy útil, muy, muy útil. Y el jet lag social no es tan problema. O al menos yo, en vuestra clínica, son muy pocos los que me cumplen más de 2 horas de jet lag. Más de 2. Muy poca gente. Muy poca. Y a estos estudiantes te lo harán si les fuerzas horarios entre semana, porque si no, si uno hace lo que desea, si uno puede hacer lo que quiere, no hace jet lag social. Bueno, a no ser que salga a beber ese día y que salga de juerga, pero si no, no.
El cuestionario de Karolinska, que tiene una pregunta que básicamente pregunta cómo te consideras y que es muy bueno también. Lo que tengo a decir, cuando hablamos con niños, algo que muchas veces tenemos los niños vienen con los padres, preguntamos a los padres, y después preguntamos a los niños. Y es completamente diferente.
Claro, los padres dicen cuando se van a la habitación, a los niños.
Es muy importante hacer la pregunta diferente para los dos. Ver la discordancia, porque la discordancia es está cuando no tienes un problema. Claro, es la discordancia muchas veces.